I don't know. I don't want the officers.
Why? Get your own thing. Like, you know the red pants I have?
Okay, good to see you guys. We're recording today, okay, so that we can help the freshmen out.
Hi, Mom.
You can mess with them, yeah, absolutely. Say hi, freshmen. Say hi, freshmen.
Hi, freshmen.
And other people are out.
Hi, David. I know you're at the art museum right now, so yeah. What's up?
Is that all you have to say?
We wish you well, freshmen. Okay.
You should just make a music video instead. Well, I mean, if they do Jordan, then we get a curve.
That's true.
What's up?
Okay, so we're starting a statistics unit, and I thought I'd share this photo with you. It's from a trip I took to visit. You're right, it's in Twin Cities. I was visiting my friend, a professor in mathematics, Dr. Wright, in Minneapolis, and we decided to have a little picnic down by. This past summer, and we decided to have a little picnic down by the waterside. Beautiful. And then we were down along real close playing frisbee and stuff, and then we went to. Anyway, I saw the sign down by the water, and I thought this is amazing that this unit would be captured on this sign out in another. It was just too coincidental.
That's their shadow, right?
Yeah, no, is that another sign?
No, that's the other sign. Yeah, come on.
Why do they have a sign?
I mean, it's certainly not been photoshopped. Is that what you're asking? Taylor has a question already. Okay, go ahead.
Did you celebrate Pi Day?
I did. Yeah, didn't you?
9.
I had I ate pie. You didn't forget. I hope everyone did celebrate Pi Day. So we're gonna do. I'm afraid we're gonna do some things that are somewhat boring on the first day of statistics. And by the way, this is a little bit of a short unit, so you can check out the schedule there. But just have a couple homeworks. And in fact, as a teacher, it's hard for me to understand where we should separate, pedagogically, where probability ends and stat begins. In fact, some people teach them in the other order, and it's, I don't know, right? Because we're gonna hit again. We're gonna talk about probability distributions again, and we're gonna still talk about expected value even right now today, and we're still gonna, right? So there's a lot of overlap here, but we're gonna frame some of the things we were talking about last unit. We're gonna address some new things that we haven't thought about for sure. We're also gonna address some things we thought about last unit, like expected value or like standard deviation, in a new, maybe in a new light, right? With statistics in mind. So, for instance, now, I don't think you'll have to take too many notes today at all during this little lesson, because my notes for you are in this packet I gave you. I don't normally do that, but I thought there's so much of this stuff that you already know. I just assume everyone, whether you're taking stat or not, coming into this already knows how to compute the mean, median, and mode, and you know how to maybe. By a show of hands, let's ask a few questions. I think I don't need to ask that one. Everyone should know how to calculate those three things. But what about, we're going to do a box and whisker plot. How many people remember how to do a box and whisker plot? Maybe vaguely, okay? Good. All right, so maybe I'll even skip that, right? If you really aren't confident enough to do it, or maybe I'll make someone come up and do it. Feel free to, as usual, in fact, I always encourage you to do this, but feel free to race ahead in this packet, right? There's nothing in here. I'm going to give you full instructions, too, on how to do them. So I want to just, as I lecture, I'm going to lecture in a little bit of a different way than I normally do. I'm going to skip things and mumble, and then I'm going to highlight the things I think are really key that maybe you haven't thought of. Okay? So I'm going to assume a lot of prior knowledge, even for those who haven't taken the stat, because I think you've thought about the first quartile in your life before, and I think you've thought about the interquartile range and all these kinds of things. Am I right? Okay, we'll refresh your memory. It's all written on this sheet too, so feel free to look as we go. I have just these examples up here. The first one we'll look at is Miss Jessel's house. We went around and took a survey. We took a sample of 10 weeds from her house, just randomly selected, and these are the lengths we measured them to be. Okay, she really needs to get a gardener or something. All right, so feel free to use your calculator here on these.
78.1. That's really.
Yeah, there is 78.1. That's taller than me, by the way. Measured in inches. Okay.
Oh, so centimeters.
Oh, no, 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 yeah, you're right. Are they centimeters, not inches? Okay, then I take it back. That's not quite as tall as me. It's only about half as tall, less than half as tall as me. All right.
But that's still pretty tall.
Did you guys know that I'm exactly 2 meters tall? 200 centimeters tall.
Nice.
Isn't that remarkable? Okay. It's easy to remember my height in centimeters. 25.8. So feel free to put these in your calculator if you haven't already. I saw some people already mashing buttons. Go for it. Yeah, this stuff is kind of annoying, and we are emphasizing, for sure, we're emphasizing calculator skills a little bit. Outsource as much of the process as you can. 31.8, 78.1, 33.6. All right, how do we make sure we entered those correctly? Were there actually 10? Was it 10?
Yeah.
Okay, so I just got 10. Did you see that? I can check that by just looking here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think I got them all. I should just review the list a little bit. Make sure I typed them in right. 25.8, 21.9, 24.2, 26. All right, I'm pretty confident that I entered those all correctly with no errors. If we wanted to find the mean of these without the stat feature, I just want to show you some of the other features of your calculator too on your list. For instance, if you want, I think we did this the other day, right? You could go to, if you wanted to get the sum of these things, then you can do sum L1, excuse me, L1, and then that's that. And then if you wanted to say the average, you want to compute that, not the, or the expected value, same thing, right? Expected value, mean, average, same thing. Then you could do that by hand without 1 bar stats by doing what I just did, and then anyway. And then divide by 10, right? Which is actually, we don't need to type that into the calculator. We could have just known that before, right? So our mean, did anyone run 1 bar stats yet? Okay, is that what you got? We'll do it too. Did you get 33.95 for the mean? Thumbs up from Simon at the back. Okay, so you could do this by hand. I want to make sure you remember how to do these by hand too. Of course, it's the sum divided by 10. Beautiful. What's the median? How do we get that? It's the 50th percentile? Okay. 1 bar stats will tell it to us. If we were to do it by hand, what would you have to do? Everyone should know how to find the median by hand because you did it like elementary school. So, Jen, you can tell us. Go ahead. Find the middle number. Okay, so I'm up here. Let's see here. 28. All right, good. Is that what you meant? No. Oh no. It has to be in order. Okay, so let's see. I think that maybe there. Look, sort A. Maybe that'll do it for us. Let's just see what that does. I don't know. Do you think that'll do anything for us? Done. Oh, really? Okay. Look at that. It's in order. Beautiful. Okay. You can also compute using 1 bar stats, right? But if we were to do it by hand, now it's in order. We could look at it. I just want to make sure you're familiar with some of your calculator features. So where is the? That's a good question. For 10 pieces of data, how do we find the center of the data? Yeah, what are, and I should have started by saying, how do we find those middle numbers? I mean, what are they? The 5th and 6th value, right? Okay. I know that's a little bit of like, oh, like duh, but it's not quite. We're going to do it with like hundreds of pieces of data later, and I want to make sure, like, you better not be doing, I'm just saying, for this list, it might be sufficient to be like, oh, cross off, you know, you haven't, suppose these are in order. Cross off, but like when we're doing 600 pieces of data, please don't write it all out and start crossing off from left and right and like until you get to the middle, right? But, so yeah, maybe actually think a little more about it. Oh yeah, it's going to be in between the 5th and the 6th piece of data. So up here, that's so the average of this piece of data and this piece of data. Yeah. So do that, and you should get the same thing 1 bar stats does. I've been talking about 1 bar stats, so let's just run it here and see what it does for us. Calc 1 bar stats. Boom. And does it give us the mean that we calculated? Sure does. Does it give us the median? Yeah, if we scroll down, it gives you the median. It gives you some other stuff too. Right, there's the median. That should be the average of those two things if your calculator did it the way we just did it. It gives you the number of pieces of data, 10. And it gives you the standard deviation, which I'm going to ask for down here as well. And the variance, you'll have to square it to get that. It doesn't give you the range. What's the range? The highest value minus the lowest, max minus min. Okay, so compute that. I won't do it for you. Go ahead. Q1 and Q3, you can write down from your calculator, and someone also remind us what those are. Then, what is Q? Ryan, what is Q1 or Q3? Do you remember what those mean?
First quartile, third quartile, it's like
What are they?
the middle between the lower extreme and the median for quarter one, and then the median, and then the upper extreme for the quarter three.
Yeah, okay, so it's the, one way to say what Q3, Q1 is, it's the median of the lower half of the data.
Yeah.
And Q3 is, okay, but also you can say Q1 is the value which separates 25, the lower 25 from the upper 75% of the data, right? All right, so a couple ways to conceptualize it. And those also, like your calculator will do for you, different pieces of, and even though it seems like a really simple concept, different pieces of respected mathematical software calculate those things differently, believe it or not, okay? But the general idea is what we just said. I wouldn't get too caught up in the minutia of it. So it gives you lots of helpful things. It gives you the min and the max. It doesn't give you the range, but there it is. You could subtract 78 minus 21, you know, with 78.1 minus 21.7, 21.9. It gives you sigma, which is our standard deviation. S, ignore, stat people. Sigma squared, ignore. Sigma x is maybe useful, right? That's the sum of all the data, okay? But whatever, okay. Everyone good with that so far? Now notice when I ran one-bar stats, look, it should make sure we're clear, because I think when we ran one-bar stats in our probability unit, we often ran L1, L2, okay? And we're going to do that today too. If you want to put frequencies in L2, you can, but what would the frequency of all these pieces of data be? It's just defaulting to 1, right? So you could do that if you want. You could run one-bar stats L1, comma L2, and in L2 you put 1, 1, 1, 1, 1, 1, 1. Dumb. Don't do that, right? It just assumes if you don't put frequencies in L2 that the frequencies are 1, right? How many weeds did you get of length 25.8 centimeters? Well, if you don't tell me, then I'm just going to assume it's 1 of them, okay? Let's say something, and then the IQR is Q3 minus Q1. Again, your calculator doesn't give that to you. You know how to do subtraction though, so yay. All right. Let's say something about standard deviation in the new context of statistics, because you're like thinking, how do we compute standard deviation? I gave you a formula. And the way it went was, you know, it used probabilities, didn't it? Well, I don't see any probabilities here. Now, this is a little hard to do with this last example, so maybe I'll generate some other data here to show you what we mean. All right, so this is the standard deviation formula that like you would see in the context of statistics, okay? All right, this formula, and it should look at least somewhat familiar, but there is some new stuff happening here. There's this like frequency thing, that's Fi. Each piece of data we're calling Xi, the ith piece of data we're calling Xi, and then its frequency is Fi. So in the last case, Fi for all of them was 1. Not very interesting. But imagine you had some, like we took a survey, and some people responded 10, some people responded 11, some people responded 12, some people responded 13. And we surveyed lots of people, okay? We surveyed, and like 5 people said 10, 17 people said 11, 14 people said 12, and 2 people said 13, okay? So how would we do all of our statistics? Let's go back to the previous page here too. Could you do one-bar stats with this? Actually, on your calculator, it'll do great, right? So you put this in L1 and this in L2 and run one-bar stats. It does everything for you. It's great. How will it compute the mean? Well, it'll add these up. Well, be careful though. Are these the values we're averaging? 10, 11, 12, and 13? Well, yeah, but there aren't only 4 values now, right? You understand what the frequencies mean? Does that make sense? How many pieces of data are there actually here? Well, if you add up the frequencies, right, there aren't just 4, whatever this comes out to, I don't know. Is it 38? Okay, we'll go with it. N equals 38, okay. So now, how would you find the standard deviation? Well, again, you feed it to your calculator, right? But how is your calculator doing it? Well, it's using this formula right here, right? It's doing every value minus the expected value, or the mean, squared, and then times this frequency over here, sum those all up, divide by 38 in this case, and then take the square root. If you're finding standard deviation, don't take the square root if you're finding variance. Yeah?
On the test tomorrow,
Yeah.
do we have to ever find standard deviation by standard?
You can just use the calculator. I want you to like understand these formulas, but like as long as I think we did go through one by hand last unit, and that's good. Like, right, like once you've gone through this once by hand, then I hope that's good enough for you. I just put up actually the formula from last unit, just as a comparison. Are these really the same formula? Do you remember this formula from this past unit here? We've been talking about as value minus the mean squared. Okay, that sounds familiar up here. But down here we've got the probability. What's going on? Is this the same formula? I want to make sure, because in this context of statistics we might use this formula, but in probability we're kind of thinking about it this way. Are they the same?
PI over like something over n.
Yeah, let's highlight the difference. This and this are the two differences in these formulas, right? And for any given the ith value, we might in fact up here, like if we didn't want frequencies, instead if you wanted probabilities, could you do that? Could you list the probability of each of these values? Instead, over here, what would they be? What's the probability of this guy, of 10? Isn't it 5 out of 38? Isn't it the frequency divided by the number? Isn't that P? So what I'm saying is that PI is equal to FI over N. And so do we need two formulas? We don't, but in different contexts, people might give it to you one way or another. And I want you to understand that they're the same, really, right? Makes sense? And so if you give your calculator L1 here, L2 here, it'll also find the standard deviation and give you the same thing, right? It doesn't matter. It's just looking for the proportion of the values. So either way. In L2 you can put probabilities or frequencies and it'll do a great job either way. Okay. And remember, like I've been emphasizing time and time again, even though this is a good discussion, I hope you understand where standard deviation comes from and what variance is and how it measures the spread outness of the data. In the end, we will feed this to our calculator most of the time. Okay. Just want to make sure you're clear on that. Okay, how do we make a box and whisker plot? Let's say something about that, because it sounds like you guys all remember, but as far as but let's review, because I have certain expectations I would want you to see if you did it. So again, let's emphasize again that we're going to let your calculator do this, okay? So let's see if we can get this to happen. Make sure nothing's in y equals, right? Clear all your equations out. Then go to stat plot, second y equals, and then turn on stat plot number 1. And I think you've done this all before, right? You've seen this menu in your life before, haven't you? And I think you've done a scatter plot. Everyone has done a scatter plot, right? Huh? How do you get there? You go to second y equals the stat plot. So is everyone on that screen? Then go to stat plot 1, turn it on, make sure it's on up here. And then I think what everyone's done before, you've at least made a scatter plot, right? Am I right? That everyone at least one time, you've forgotten maybe how, but you've made scatter plots on your calculator before. There are other things you can make too, right? You can make a line plot, whatever you call it. You can make a histogram. We might have an interest in doing that today too at some point. And then there are two down here that are box plots. So the first one is just this one in the middle and the bottom is like a normal box plot, okay? And notice that it asks you for L1 and frequencies in L2. Now we actually for this data we don't have any frequencies, right? So we can just put 1 there, right? The frequency for every single one is 1. So that's how you handle that situation. And then if you go zoom, stat, hopefully, usually this does a good job, not always. It should provide for us a decent window on this, okay? Should it make sure that the minimum value and the maximum value are captured in its x range, you know, okay. What significance does the y coordinate have on this picture? None, right? It's just, there isn't any, okay? If you trace this graph, you'll get the five-figure picture of this data, the min down here, the first quartile, the median, which is also the second quartile, Q3, and then the max, right? That's what a box plot looks like. Do you see it? Captures all the data. Yeah, and actually here, just to be clear, let's put a scale down here. We're going to put a scale underneath of our box plot. Do your calculator, you can copy this right off your calculator, it's not a problem. What do we say? The minimum value is 21 something, right? And the maximum value is 78 or something. So let's see if we can get this on here. I'd like to see 20, 30, 40, 50, 60, 70, 80. Okay, I'm not being like super precise, but I want to at least have some uniform scale. Keyword uniform, right? Because what I see people do is like make some random box plot and then add a scale. That's like the wrong order to doing it, right? Because the whole point of the box plot is that we see how stretched out the data is. And if you have like 78 right next to 33 or whatever, right? That doesn't show us the distribution of the data. That's like the whole point, is to show you the distribution of the data. Where's my calculator? Okay. So I can just copy these right off of here. This is, I want to make sure you're clear on my expectations for what I want on the box plot. 21.9 is down here, say. We don't have to be perfect, but let's just say that's 21.9. And I'm going to label that the minimum. And then 25.8 is Q1. I maybe put that in the wrong spot. Whatever. And then, I mean, this is not that fun, just so you know. 29 point. Ugh. This is all squished down here, right? Okay, this is not like our shiny moment here. Let's see if we can get these labeled properly, nicely. We could label it up top or something. Okay, where are we going up to? 33.6. Ugh. How about somewhere in there? Okay. And then we're going all the way up to 78.1. All right, that's easy. We can label that. We're all crammed down here, down at the bottom, though. All right. So this is what I would expect here. Q1, Q3. And say what those are. 33.6. 25.8. Okay. 29.9. All right. So I think that's as technical and as terrible as this could go. You know, in an academic context, do we ever see box and whisker plots? I mean, you certainly don't see them very much in like the normal person's media. Like, I mean, when's the last time you saw a box and whisker plot in the wild?
The stock charts, like when there's size.
Yeah, sometimes you'll have vertical ones that on stock charts and things like that. So maybe you see them depending on what you're looking at. And they do use them in certain academic contexts and journal articles and stuff you'll read. So they are useful, but it is true, you don't see them very often. Like, when was the last time that you saw that as like a thing in like a newspaper article or something like that for the common person? Well, actually, this is a cool example of one I saw recently that I was like, actually, this is actually a cool use of box plots. Well, box plots to me are usually like kind of boring and sometimes stupid, and not necessarily the best way to visualize something. But this is cool. Look, are you ready? So this article, this is out that's on the 538 blog, which is Nate Silver's group of people doing stat stuff. They're the one. Nate Silver is the one who like got a lot of credit for calling really accurately all the state outcomes in the last presidential election, and people were like, "Whoa!" Anyway, so this question is like a cool one, right? And I think vaguely, like before we actually look at these charts, if someone said like, "Oh hi, my name is like you know, John. My name is Beulah," you would be like, "Oh, you're probably what age? What do you think?" 70, right? Exactly, right? So there's, in some vague sense, you understand that someone could probably guess someone's age, like, you know, based on their. Now, some of you in this classroom have some interesting names, right? So we should do this like with a broader range of names, or somebody. I don't know. We have only the most common names on here. But still, this is cool. So here, let's start with this one here. This is the median age for males, with 25, for the 25 most common male names, okay? So like, you see what this is saying? These are actually box plots, right? Now it doesn't give all the details like I'd like you to do, but it's the general picture, which is pretty useful here. This is the middle 50% of the data from Q1 to Q3. So this captures most of the kind of the central part of the data. So if you're a Joshua, then we're going to guess that you're between 20 and 30 probably, right? That's our bet. Yeah? So, you know, is that good that people think you're older than you are, Joshua? In the back?
Yeah.
Okay. But if you're like a Donald, like some people were laughing about, that's probably like, you're probably 50 to 70 years old. And wouldn't that be accurate? Like maybe your grandfather or something is named Donald.
Donald Sloan.
So there you go. Where's my name? John. Okay. I'm pretty, pretty wide span there. Some names are classic too. We'll look at those too. There's the most common female names. Look, see, like Anna, for instance, is pretty. Anna is pretty timeless, right? It's like we don't know how old you are if you're Anna maybe. But if you're a Betty, we're gonna bet that you're like old, okay? And the red dot is the median, right? So there's some block. It's almost a box plot, right? It's missing the min and the max. That's cool. Ruth, we named our daughter Ruth, so that's coming back though, okay? Just so you know. I want to focus on the box plots. There's some other interesting stuff. You should go check this out for sure. This is the youngest male names. Youngest male names now. Okay, so odds are that if you're like a Liam, and right, you know from experience that this is true. Odds are if you're a Liam, you're like probably 3. I know we were talking about age.
But that's like, yeah, that's.
Look at Oliver. Look how timeless Oliver is. I mean, that's a strong name. Like I don't know how old you are. You can be. That's great. I like that. Okay. Oldest male names. This is my dad's name. My dad is Gene. But yeah, and you can see lots of old people here, right? When you see these names, you think old people, don't you? Okay. Youngest female names. Let's look at those just for fun. This is fun.
Is it Ava or Ava?
Ava, I think is maybe how you'd say that. Yeah.
Sophie.
Is this part recording for the break?
Yeah, absolutely. They're gonna love this. They're listening. Well, not right this second. Later when.
All their names.
Do we have any freshmen name those things? I don't know.
Yeah.
Yeah, Ella. That's kind of that's interesting. Yeah. Again, it's maybe a timeless name, I guess.
True. Oh my God. Beulah?
I grew up knowing a Beulah.
That is such
and,
like Merle Wilson.
But they're old. I mean, you might even think later. There's a chart that answers this question too. You might get to the point where you think like, hey, if someone comes up to me and their name is like Beulah, like maybe there's a strong sense that like they might be dead, right? Like you're either right, like they're either.
Then why are they coming up to you?
Oh, okay. Look at this. This is cool. Maybe this is not box plots, but we could just mention here. Like, this is cool. Violet. We got violet. Lots of old violets, but also really a lot of young violets. It's nice bimodal distribution, right?
Coming back, right?
Oh yeah, it's coming back. Maybe. It's probably because of what's the movie that has a violet in the Incredibles? Right. No, I don't know. I don't know. Names with the widest age spread, so these would be maybe the more timeless names, right? Right? We don't know how old you are. If you're a Cora, yeah, that's kind of, you could be 8 or you could be 7. That's cool, right? All right, here are the dentist names. Right? So if your grandmother's name was Mabel, then like there's a 90.8% chance that they're dead. Right? Well, don't laugh too much. I mean, someone might have a very sensitive moment right now. We don't know. My grandfather's name was Claude, and he is dead. It was years ago, but he rests in peace.
Taylor, what's Kristen Stewart's name in Twilight?
Anyway, fun to look at these things. So actually, didn't we just have fun with box plots? We actually kind of did, and we have to admit it. But normally box plots are dumb. Okay, but that was kind of cool actually. Okay. How do you make a modified box plot? You can calculate the outliers, and let's introduce that term now too. Or your calculator can do it. Yeah, exactly. I'm going to feed it to my calculator again. So let's at least briefly say what IB / your calculator says an outlier is. And other people I think use this definition too, but it's really somewhat arbitrarily decided upon. Okay, and this is written there. Everything I've been saying is written on the paper too. But it says an outlier. We're going to consider an outlier. A piece of data is an outlier if. Well, first, compute the IQR. Did we say what that is? We should stop and say what that is. That's Q3 minus Q1. So figure out what the IQR is. Multiply that by 1.5. Are you following the recipe? And then add that to Q3. Anything above that, we're going to consider an outlier. It's so far away. And take the IQR and subtract it from Q1. Anything below that, we're going to consider an outlier. Okay, so those would be the outliers. You might have a sense that 78.1 for our data was an outlier. But is it? That's a good question. Does it actually follow this recipe? I think I designed this data so that it would be actually an outlier, so that it would be interesting that we'd have something to talk about. Yeah, so let's, you could actually compute it by hand, but again, we're going to actually make our calculator do the modified box plot as well. Where's my calculator? Here it is. So instead of a box plot, you choose, go to your stat plot, if some of you have maybe already figured this out. There's another one here. This other box plot, you see how it has little dots there? Those are the outliers. This is going to show the outliers. Yay. And there it is, right? If we trace now, you can see it gives you the min, Q1, the median, Q3. Then that value right there that we're blinking on is not the thing that, I want to be clear, that's the last value that is not an outlier. Does that make sense? It's like the maximum value of the data if all outliers are removed. Does that make sense? It's not the cutoff 1.5 times the IQR plus Q3. It's not that cutoff point for what makes and doesn't make an outlier. It is the last piece of data that is not an outlier. Is that clear? The difference? Okay. So that is actually a piece of data in our list, right? Right there. Okay. So anyway, you just do the same thing we did on the last one. Just erase the long stem on the side, and you'll have a modified box plot. Take it out to 36.3, and then make that 78.1 just hanging out there off to the side. That's called a modified box plot. It shows the outliers. I don't have anything else to say about that. If you don't, let's say something about a stem and leaf plot. Again, stem and leaf plots are. So have you heard of stem and leaf plots at least, or you thought about them, or someone? Okay. They're also kind of dumb. I don't think that we're gonna give you a quiz or anything. I don't think we're gonna make you do one again. And I don't know that IB. Just looking at past IB tests and all the IB textbooks I've looked at and stuff, they always talk about stem and leaf plots, but I've never seen one on an IB test. I don't think. So anyway, we'll mention it right now, and then like I may never talk about it in like the history of the world again. Okay.
So like if there's like a stem and leaf plot on the IB test, like just that one time we take it.
If it does, I think you'll be okay. I think you'll be okay if you do see one, because and then you'll remember back to this very moment right now, okay? Because I will show you it was one time, okay? So we're going to put some stems over here, and for this data, we've got data in the 20s, 30s, right? And then we have data all the way up to the 70s. So I'm going to put a 2, 3, 4, 5, 6, 7, and that's it. Those are our stems, and then our leaves would be. You guys have this data written in order somewhere? 19, I think. Is 21.9 the lowest? What's the next one? Help me. I have it in order on my calculator, but 24.2 is the next one, so 42. And then 25.8? Yeah. So 58. Okay. All right, and we can keep going here if you like. Continue, right? Yay. You'll have some here, you'll have some here, and here. You won't have any here or here or here, right? Because there isn't any. And then we will have one down here, 81. Now that is completely and totally confusing, unless you have the other vital part of a stem and leaf diagram, and that's the key. All right, so this key is not just like kind of an extra addition that's like not necessary. It's absolutely necessary, because what is this? So we write something like this. We write 2/42 as an example equals 24.2, just to tell everyone what this means, because otherwise they would have no idea. You with me? Okay. Make sense? So I didn't finish the stem and leaf plot. You can do it. Okay. It's supposed to be. Oh, one other highlight here. Let's make sure we know. You're supposed to have these ones here. 4.5, 4, 5, 6. You might be like, why don't we just collapse this and not have these empty ones, right? But that would be wrong, because like the point, there's not much going for a stem and leaf plot, but let's not rob it of the thing it's trying to do, at least the one thing it's trying to do, and that is to create kind of a real crude histogram. Isn't that what this is kind of? If you like turn your head sideways and look at this, you should get a feel for like what the distribution looks like. And if you were to like compact this so that 7 is up, you'd suddenly think it was something that it isn't, All right, that's all I have to say about stem and leaf plots. All right, we should talk about this kind of data too, right? This is cool. This is a lot of data now. It doesn't look like it. You're like, oh, we surveyed people and they gave 8 different answers. They said how many TVs they had. Some people answered 0, some people answered 7, and all sorts of things in between. Okay, so there aren't just 8 pieces of data though. How many pieces of data are there here? Well, it actually says in your packet there. It says 600, so what must be true about these frequencies? Hopefully they add up to 600. We took a survey of 600 people, unless people abstained, which I would call them for that maybe. We have data that adds up. No one answered 6 TVs. Okay, I don't know how accurate this is. I just made it up, so whatever. I'm actually down in this category. I don't have any TVs in my house. I have a computer. I have a computer. I want to watch movies. I don't have any TVs. How do I survive? I just mainly do math in my spare time. Just do math. If only that weren't like somewhat true. Okay, so this is fun. This is good. How do we understand the things we've been talking about though in this light? Well, again, actually, you can just use your calculator, right? L1, L2 though this time. 1 bar stat L1, comma L2, and it works great with frequencies. So give that a try. It'll give all these things to you. How would you compute the mean by hand? What is your calculator doing behind the scenes to compute the mean?
0 times 5.
Yeah, exactly. It's 0 times 5 plus 1 times 123 plus 2 times 241 plus etc. all over 600, right? Because we want to be clear, that's how many pieces of data we have. So that is how your calculator is coming up with a mean when you do 1 bar stats L1, comma L2. Is that the same thing as, is this still expected value? Is this still the expected value? Because we conceptualized it a little, again, we conceptualized it in terms of probabilities in the last unit, in this past unit. So is it still the value times the probability? What's the probability of having 0 TVs? Yeah, isn't that 5 over 600? So it's 0 times 5 over 600 plus 1 times 123 over 600. So it still is actually the expected value calculation from last. It's just thought of in the way that maybe you, I don't know, slightly different way of writing it. The median you can get from your calculator. Again, how do you find the median for this set of data if you were to do it by hand? We're going to ask the same question again. You said you put them in order, and then yeah, exactly. You start crossing them off. You write them all out. 0, 0, 0, 0, 0, 1. Right, 5 of those. 1, 1, 1, 1, 1, 1. 123 of these? I need some more. Okay. Right, there are 5 of these, and 123 of these. And then we finally have a 2. Okay. 2, 2, 2. And then 200. All right, you get the idea. There are 241 of those. Okay. Okay, so I want to make sure at all times we don't forget, we don't lose sight of the fact that this is our data, right? We have a whole bunch of 1s, a whole bunch of 2s, right? This is the list of data in order. So how do you find the median of those? Yeah, crossing them off on either end, and coming toward the center is maybe not the best option.
Yeah, the frequencies. Like subtract 4 from 7 5.
Yeah, so where is we have 6, let's be clear, we have 600 pieces of data. So where is the median? Yeah, it's good. It's the 300.5th piece of data, actually, right? It's not the it'd be easy to say, 600 pieces of data. It's the 300th piece of data. That's not completely true, right? If you have 10 pieces of data, we just talked about at the beginning of the day with the 10 weeds, right? It's not the 5th piece of data. It's the average of the 5th and the 6th, right? So let's be careful thinking about that. Now, how do we even find the 300th piece of data in this list? We write it out like this? Well, that's not convenient. We haven't talked about the cumulative frequency down below, but that's the number of values that are in that category or below it, right? So how many are in this category or below it? 5. How many are in this category or below it? 128. How many are in this category or below it? 369, right? Etc. So you can fill this out. And what should be down here? This should be 600, right? Okay? When we're all done. Why is that helpful? Why is that helpful? Well, I claimed it was helpful. Well, that means that the first number is a 0, the 5th number is a 0, all the way up to the 5th number are zeros. The 6th number is our first one, all the way up to the 128th number, which is our last one. The 129th number is our first 2, all the way up to the 369th number, which is a 2. And then the 370th number is our first 3. Are you seeing how this works? Okay, so does that help us know where the 300th piece of data is and where the 301st piece of data? They are both, it's not very interesting here. They are both 2s, aren't they? And maybe that wasn't clear before without this cumulative frequency stuff. So that means without any fanfare, the median is 2. And your calculator will tell you that too. But I want to make sure you're thinking about this because your calculator doesn't give you some of the things down below. I want to make sure you see that. What's the mode, by the way? 2, right? Because it's just you're looking for the most frequent piece of data. Okay, it's a 2. How do you find the quartile 1? Well, you can do that in your calculator as well. That's fine. It's the median of the median, the lower half of the data. How do you find these values? Second decile, 44th percentile? Well, did you hear? Here's my secret formula, and I put it on there too for finding the median. It's you go 50% of the way through the data, except we don't want the 300th piece of data. We want the 300.5th piece of data. So we do n plus 1 times 0.5. That's how you find the median, is you go that far into your list. So for 600 pieces of data, that comes out to 300.5, doesn't it? I hope you see where I'm getting this. So does that give an idea of how you might compute 44% of the way into the data? Sure, it'd be 0.44 of the way in, n plus 1. All right, so there's this little weird thing going on. This is kind of off by 1 error. It's a little weird how that's happening. I want to make sure you're okay with that. So that's how you compute those. I think that formula is there, and you do the percentile times n plus 1. All right, the last thing we should say at least something about in the last 3 minutes is class data, right? So if you, this was really convenient to work with. A very nice, tidy summary of this data, wasn't it? But I took a survey of IB students, okay? And these are the responses they gave for the number of sit-ups they can do in 1 minute, okay? Is it all lies? I know. It's all lies. All right, so now this is cumbersome to work with because, like, I love the table in the previous slide. I liked having like a table with only a couple things to look at, right? You know, the TV one was great. Only 8 different responses from people who are out there. Here we have lots of responses from people. How do we decide how to like make this a little more digestible? I can't really understand this data at all just by looking at this big sea of numbers. So we set up, instead, we like tidy little categories. So if you want something like, make it happen, right? So let's put these in little bins and total them and come up with frequencies. Because right now, the frequencies would be really useless. How many people said 42? Well, maybe that's only like 1 or 2 or 3 people, right? This is not very useful. We'd have like all these numbers and then frequencies like 1 or 0 or 2 or something, right? Like, not very useful to do it that way. So we're going to lump them together. Say we want to lump them into 10 categories, right? 10 bins, or we're going to call them classes, right? 10 different classes. How would you go about doing it? Before you look at any of the formulas, it should just kind of make intuitive sense, shouldn't it? What do? You take you want to kind of figure out how much this spans. Like, what are our bins going to have to span, right? Well, let's see. What's the highest value? What's the lowest value up here?
22 and 97.
22 and 97? Okay. So if we subtract those, we need to cover a range of 75 values, of 75 different responses from people. Does that make sense? So we want 10 bins. How wide is each bin? Well, you take 75, a distance of 75. You want to cover it in units in 10. So 7.5, right? With how big each bin needs to be in order to cover the data. Now, 7.5 is like a little bit unfortunate because like we'd rather not have like a non-integer bin size if we're dealing with integer data maybe. So let's round that up to 8. So I want to make sure you're clear on where this calculation comes from because people will be like, oh, I need to memorize this. Okay, I hope it just makes sense intuitively. We're not doing anything like rocket science here. We're just trying to put this data in bins. Come on, right? Don't get caught up in all that. Can you think about why you round up to 8 before that'll be our last thought. Why round up? Why not round down? What if it came to 7? What I'm saying is if it comes out to 7.1, we still round up to 8. Why? Because you don't want what? Extra students? Yeah, you might. I think you'll find if you round down, you'll leave off something at the end, right? Because of the compounding error in that rounding. All right, this homework is not due until Thursday. It's like a kind of a 2-day homework. I mean, 3 days, but it's test. I would focus on tomorrow's test. Oh, decile, like if you're looking for the 4th decile, that's the same as the 40th percentile, right? So the median actually has 4 names, doesn't it? The median, the 2nd quartile, the 50th percentile, the 5th decile.
You feel like any aisle, you feel like a heptile or something.
Yeah, yeah, you know, you can do it how you like.
That's dumb.
Have a great day, guys.
It's not dumb. It's like really being a different, like,
Hey, yes, you have
Here, actually, you can find yours and put it in there.
I will see you in court.
Jerry, you didn't even distribute that document, did you?
I didn't distribute the document.
Yeah, exactly. So you can't sue him.
No, it's not yours, it's mine. I want my, like, you shall never have it. I want my section. You shall never have it. You shall never have it.